This is the ROS Developers Podcast, episode 126.
The ROS Developers Podcast, the ROS Developers. The ROS Developers
Podcast.
the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate this episode to all the people that are thinking there about doing professionally the design of the robots, the applications for the robots, and for that, they are starting with a simulation. Remember, you have to start with simulation. I know you want to work with a real robot, you want to put your hands as soon as possible in there, but you have to prevent some errors, wasting of time, and for that, you need to use simulations. Then, if that's how you think when you are developing for robots, then this episode is dedicated to you guys. And today we are going to talk about simulations because you have seen the title of the podcast already. But before going into that, let me tell you a little bit about the program that we have prepared at The Construct, which we call the Robotics Developers Masterclass, which is a program that gives you from zero knowledge, let's say, more or less, a high school knowledge, into a professional robotics developer in 6 months of hard training, okay? So that is going to be hard, and you are going to do all the materials, you are going to learn all the subjects that are going to make you ready to start into a job developing for robotics. We are teaching you the skills that companies require rather than the theory behind all those things. So you have a complete learning path here explained in our webpage. You are going to be practicing with real robots remotely also. So we have our robots here and you will be connecting to our facilities and practice with the robots. You will get all different types of skills, and at the end, you will get a certification, and also you can have an internship at one of the companies that are partnering with our program. Here are just a few of them that you can see on different countries, and more are on its way. So, yes, that's what I wanted to tell you. I will put a link into the show notes so you can go and check with more details. The next batch is going to open in March 2024. Then, so now we are ready, right? So we are ready for the podcast of today. And today I would like to introduce you with Buck Babich, who is a senior robotics R&D manager at Nvidia. There, Buck is working on manipulation, planning control, and simulations. And today he's going to talk with us about especially that, about simulations, and in more detail about Isaac Sim, the simulator that Nvidia has developed for robotics. So welcome to the podcast, Buck.
Thank you. Thanks for having me.
My pleasure. I had the pleasure to attend the presentation that you did a couple of weeks ago at the movie day, just before the ROSCon, and I was impressed about all the things that you talked there. I thought that it would be very, very interesting for the ROS audience to know about it. So that's what we have.
Yeah, that was a great meeting. So that was organized and sponsored by Picnic, and I thought they did a great job. I think assuming it's co-located next year, I think anyone going to ROSCon who's interested in manipulation should probably check it out.
Yes, it's a good idea. And we had a lot of fun and learned a lot. It was very, very interesting. And then so I knew about Isaac Sim and all this thing, but I suppose that the rest of the audience of the podcast also knows about it. They have heard, but there are so many terms, so many definitions that we get a little bit lost. So that's what we are trying to to clarify in this podcast. And then in order to start clarifying, I would like to ask you the first question, which is, the first question is, what is Nvidia Omniverse?
Okay. So to understand Isaac Sim, you have to understand Omniverse, at least a little. And Omniverse is a platform for simulating and visualizing 3D worlds and doing it in a collaborative way. So platform is really the key word there. It's not meant to be a solution in itself. It's a platform for connecting together other tools and to allow developers to develop their own tools on top of that basic platform. And under the hood, probably we'll talk about this, is built on a technology called USD, or Universal Scene Description.
Okay, but then if I am a roboticist and then I want to do a simulation of my robot and the environment is going to operate, then do I have to go to Omniverse and then create a simulation there? So that's the application?
Yeah. So Isaac Sim is sort of the incarnation for robotics, is how I would describe it. So, you might Google Isaac Sim, or you could simply Google Omniverse. And the installation instructions you'll see will be the same either way. You'll download the Omniverse launcher, and in there will be a reference application called Isaac Sim. You'll click, it'll install, and then you'll open that application and you'll be presented with a user interface that's meant to be a sort of baseline for building a robotics application.
Okay, so the Omniverse will be like a simulator for any kind of thing, whatever.
Yeah, Omniverse itself is very general. So it's, there are tools, lots of third-party tools. So for content creation, you might think of Maya or Blender, various simulators, like let's say FlexSim in the industrial simulation space, which is in the process of being acquired by Autodesk. There's a connector to connect FlexSim with Omniverse. So it connects many different tools, and then developers can build their own applications. And in order to do that, there's a layer called Omniverse Kit, which is sort of this compact foundational layer on which you can build your own application. And a kit-based application consists of kit along with a set of extensions, dozens or possibly hundreds if it's a very complicated application. So it's sort of this extension-based development platform for building custom applications.
Then sorry that I continue on this because I still don't get it. It's about, you mentioned about, for example, about Blender connecting to Omniverse, but Blender is already an application, so I don't understand how we benefit in some way by connecting to Omniverse. What is the purpose of connecting to Omniverse?
Yes. So Omniverse is meant to allow users to build their own workflows that involve multiple tools. And to help understand this, maybe it's worth talking for a moment about USD, or Universal Scene Description. Okay. Since that is sort of the very base layer. Okay. So USD, or it's now called OpenUSD because it's an open standard, is a standard for describing 3D worlds. And it was originally developed by Pixar, the animation studio, for their own workflows. So, when making a modern animated film, there are many different departments involved, the same way you would have in a live action movie, right? So someone might be animating the characters, someone else might be dressing the sets or designing the sets, designing, any model obviously that appears in the film, has to be modeled by someone. There are professionals who work on lighting. So you have all of these people working with 3D assets in different ways, and often they need different versions of the same asset. So for example, you might want to pre-visualize a movie to figure out blocking for the scene, and for that, maybe you need lower quality assets than you would need in the final render. Or an animator might not need the full rendering in order to animate a character. So for that reason, Pixar developed this technology called USD, Universal Scene Description, and it's tempting. People hearing about it for the first time, it sounds like a file format. It sounds like Yeah. Okay.
Let me-
Ricardo is raising his hand that he's guilty. That it sounds like, oh, it's like OBJ or GLTF or I don't know, STL if
Yeah.
you're thinking of CAD. Like any other format, it's just a way to represent a scene on disk. And it does do that. There is both a binary and an ASCII format for USD, but it's better to think of it as an in-memory representation and, a large library or framework for manipulating that data. So that's USD. It's now an open standard at SIGGRAPH this year. The Alliance for OpenUSD was formed, which is a nonprofit with 5 founding members. Nvidia is one of them, along with Apple, Autodesk, Adobe, and Pixar, of course.
Mm-hmm.
And so we have this basic standard, open source, and Omniverse builds on top of that. At the core of Omniverse, there's a sort of database for 3D scene data called Nucleus. And that's where you would sort of store the 3D scene. But that, as the name implies, it also allows other tools to connect to it. So that might be Isaac Sim as a robotic simulation platform, or it could be a third-party tool like Maya. And there are dozens, probably now hundreds of connectors for connecting different tools. And there are sort of connectors can have different levels of capability. The sort of highest level would actually be live sync, where, for example, you could be in Maya changing the scene, changing the modeling of the scene or moving things around, and it would update live in a kit-based application like Isaac Sim. So you can see everything happening at once. And, for a typical ROS developer, working with a single robot, some self-contained project, it might not be clear why you would want that. Again, Ricardo's nodding his head. But for an industrial customer who's maybe trying to plan an entire factory, and off in a corner there's a work cell with a single industrial arm, there's a lot of value to having this possibility of connection between different tools. And so that's Omniverse. Then we can talk more about Isaac Sim, of course.
Mm-hmm. Okay. I see. Then, but in our case, for example, the case of a developer that is developing, I don't know, an application for a navigation application for a single robot, and it's producing this robot in several numbers, and then every robot is going to have the same application. Then for that, if I understood correctly, they only need to have Isaac Sim, right?
Yeah, you could start with just Isaac Sim. Maybe you don't need this live sync capability. You similar to how you would set up a scene in any other simulator, you might bring in your robot. We can talk specifically about how that's done. Model a scene of any complexity. It could be very simple for a navigation application, right? Maybe just you need a ground plane and a few objects to avoid, maybe if you're just starting out. And yeah, you're working within one application. It's all scriptable. There are various ways to program your robot application or connect to a ROS-based control stack.
Okay, and then why? Can I ask you why Nvidia decided to build such a system, especially Isaac Sim? But now that I understand better what is Omniverse, so. Yeah. Why to build this whole application Omniverse? But where is the business for this?
Yeah, so Omniverse, it's finding use cases in many different industries. So here we're talking about robotics, but factory planning is a good example where robotics is one aspect of that. But there are companies, let's say an automotive company might be building a literal million square foot, 100,000 square meter factory, and has to plan out the workflow in that factory. And maybe they're leveraging some existing tools. Maybe it's FlexSim, maybe it's Process Simulate from Siemens, and there are all these different tools. But what Omniverse adds on top of those tools, first of all, it provides a way to connect them together. But it also provides very high fidelity visualization. Nvidia is good at rendering. Yes. So it includes high quality renderers, and the renderers are selectable. It also, for applications that need it, provides high fidelity physics simulation, which is the other aspect, and is certainly important for robotics. So there's that use case, but of course USD came from media and entertainment, so there are use cases there. There are use cases for architecture, engineering, and construction. So there are all these industries that have the buzzword is sort of industrial digitalization, right? It's basically bringing the physical world into the virtual world. You could call it the metaverse if you'd like, but this is sort of a very concrete, practical use of the metaverse, if you want to call it that. Okay.
But then, so the business is on selling licenses of Omniverse, but
so for enterprise customers, for a customer that needs support or needs capabilities beyond what like an individual developer needs, there is an enterprise license. It's also possible to deploy in the cloud and so on. The key thing I think for maybe a typical ROS developer is that for an individual, Isaac Sim, for example, is free. You just download it, install it, start using it. It doesn't matter if you work for a company or university or you're independent. You can download it and start using it immediately.
Excellent. Okay, that's what the audience wanted to hear.
Yeah.
No, okay, so we understand those are business. Everybody's trying to make business, and then it's important to understand, so where is the business? So we support the business, of course, part. And yeah.
Yeah, I mean, ultimately we think it has value, so we want it to be sustainable.
Exactly.
And so that's how it's supported.
Exactly. It's important. It's important to have this model. Okay, and then, so how accurate is the physics of the simulation in Isaac Sim?
So Nvidia has, over 2 decades now of experience in physics simulation specifically. In the early days, that was mostly for games. That's where a lot of the heritage is at Nvidia. If you go back beyond, let's say, the last 10 or 12 years, where we've really become an AI company. So there's a physics engine called PhysX with a capital X. And as I said, the original heritage is in games, but for, I don't know, nearly a decade now, a lot of effort has gone into making, for example, the rigid body simulator suitable for robotic simulation. So for the experts, that would be, reduced coordinate articulations and everything in there is GPU accelerated. So it takes full advantage of the GPU, which is important if you have a complicated scene, or let's say you're simulating many instances of a scene for the purpose of training either perception systems or policies for control.
Yes, I have seen those amazing videos where there are like hundreds of the same scene but replicated. Each one is training, right? Doing reinforcement learning.
Exactly, and it's amazing how, if you can compare what's possible with and without full GPU acceleration, the difference is amazing. It's not one order of magnitude; it's many orders of magnitude, and the benefit comes from having the full pipeline on the GPU. So GPU is graphics processing unit for anyone who doesn't know, but these days GPUs are used for much more than graphics. They're really general purpose accelerators that are used for all kinds of machine learning problem simulation, as well as physics and rendering, of course.
Yes, but in those videos, so what I see is the same scene that is being replicated, and each one is doing its own training at the same time in parallel. But then I have a use case that never seen, or I think I have never seen, which is similar. Let's say we have a warehouse, a complete warehouse with 100 robots in there. So I've never seen this kind of simulation. So is that also possible? Because in that case, there is the problem of the concurrency of the physics threads, right? That they have to interchange information, and then
yes,
you cannot parallelize.
It's absolutely possible. It, in fact, it's designed for that, for having many robots in the same scene. Now, there is a caveat, which is if you're doing, one of the benefits of Isaac Sim and Omniverse in general is high fidelity sensor simulation. So let's say that each of those robots has a camera, that's being simulated at full resolution, right? So that means you're rendering view into the scene that's maybe photoreal or approaching photoreal for each robot. As you can imagine, that is a lot of computation involved. And so you might be limited in the number of individual cameras that could be rendered on a single node, let's say. Now, for some customers, another focus of Omniverse is scaling to the data center, where you can have many nodes, many GPUs all collaborating on a single scene to help make this possible. But for the typical user running Isaac Sim on their workstation, there will be limits in terms of what you can do in terms of sensor simulation, let's say, for many robots.
Yes, but I understand that because it's a computer and then it has resources, but actually the main problem of the robot simulators is not that they are confined into a single computer, but that they are. Imagine that you have as many cloud computers as you want. Okay, so you have it because we have it. If you pay, you can have it. Okay, so now you can use that to simulate at the same time the same scene with 100 robots. That is the problem. So because all the robots, they share the same physics loop, update loop. All the robots. So there are ways of separating in islands when they are not close to them enough. But I don't know if that is possible in Isaac Sim.
It certainly is in Omniverse. There's an underlying technology that allows us. So USD itself, to be clear, in principle allows synchronizing data between different nodes. Now, the problem is doing that with sufficient performance is challenging. So there's actually a layer that sits above USD that's part of Omniverse that helps make such synchronization efficient. And so relying on that, it is possible to have shared worlds between many nodes. Now, I think for most users of Isaac Sim, typically they are running on a single node, even if it is in the cloud. And Omniverse is under very active development. So these capabilities, especially ones focused on scalability, those are continuing to improve, as we speak. There are literally hundreds of people working on that. So, I mean, for many of the more traditional use case taking advantage of massive parallelization that I mentioned, which is sort of training.
Yes.
For RL, that's where we've seen a lot of use. Another is synthetic data generation for training perception systems. So, for example, maybe you're trying to train a pose estimation algorithm for determining the 6D pose of an object. In order to do that, it's a supervised learning approach typically. So you need labeled data, and you could label that data in the real world. You could take a whole bunch of photos, let's say, of your object and sort of hand annotate the photos. What synthetic data generation allows is in simulation, the ground truth pose of the object. Every pixel on the screen, whether it belongs to the object or not, if you want to do segmentation and so on. So it's possible to randomize lighting, put confusing things in the background and train a learning-based perception algorithm in that way. So these are uses that are taking advantage of the massive parallelism, of the GPU, to either train, control, or perception for robotics.
Okay, yeah. So, and then now I understand those points, and also that you are in the process of improving. So, wanted to mention that there is a market there, because many companies already ask about can we simulate our fleet of 100 robots or 20 robots or 30 robots? And they are using Gazebo for that, of course. And then Gazebo, after a few of them, just single digit, then it goes down. It cannot handle that because it's not prepared. It's not a criticism of Gazebo. It's just stating it's not being prepared for that. It's not being thought for that, for multiple. So that leads to my next question, which is, what is the difference of between Gazebo and Isaac Sim? So people that is using Gazebo now is thinking, should I use then Isaac Sim instead of Gazebo?
Yeah, so I think they're complementary in some ways. So Isaac Sim, we've talked a bit about high fidelity rendering, high fidelity physics. I think those are areas where Isaac Sim shines. And to those, I would add sensor simulation. So rendering serves multiple purposes, right? It's useful for visualization. You might, let's say even for marketing purposes, you might want sort of a photoreal rendering of what your robot is doing. But also just for debugging purposes, there's a benefit to having high quality rendering, either as a live digital twin, let's say for a robot, when you have a physical robot doing a job and you can visualize it in the simulator, or before you've deployed the robot, visualizing what the robot would do. So that's one use of rendering. Another is camera simulation, which we've touched on. And Isaac Sim provides a full suite of sensors and cameras. So for cameras, there's a camera model in Omniverse. You can simulate cameras of all kinds, fisheye lenses, stereo cameras, depth, and then closely related, there are other range sensors like radar and LiDAR that are simulated using ray tracing, which is accelerated in hardware on Nvidia GPUs, and then other sensors like IMUs and touch sensors and so on. So I think especially the sensors such as cameras and range sensors, I think that's sort of a special strength of Isaac Sim that you might not find in Gazebo today. So that's one area where I think there's a benefit to using Isaac Sim, but we have lots of customers who are using both. So they use Gazebo for some things and then use Isaac Sim for other things where they need the high fidelity sensor simulation or let's say for RL training or training perception.
Yes, and also another of the advantages is the Isaac Gym, right? Which is the module that you are using, that you mentioned already, for parallelizing the training of.
That's right. So Isaac Gym is an extension within Isaac Sim for doing what we've been discussing, right? If you have many environments that you want to simulate in parallel. And probably the most common use case for that is for reinforcement learning. For those who don't know, that the idea there is you have a robot that you would like to perform some task. And it could be a manipulation task. It could be a legged robot. So let's say a quadruped, and you want to teach that quadruped to walk in simulation. A modern way to do this is by having a policy, so might be a deep neural network of some kind that is going to control the actuators of the robot. And at the beginning, you might start with sort of a random policy where the robot's just going to fall down immediately. But by tailoring a reward function to reward the robot as it succeeds in walking, it's possible to over time, but through millions of iterations, improve that control policy. So Isaac Gym, that's just an example use case, but Isaac Gym is an extension for doing this. It's somewhat confusing if you search for Isaac Gym online, you might also find a preview release, and this is a standalone release of Isaac Gym that's separate from Omniverse. And it's been very popular, especially among researchers. The capabilities of that standalone version have been fully integrated into Isaac Sim. So these days, it's still there if someone wants to download it, but I would suggest that most folks would probably just want to check out Isaac Sim and the Gym extension within Isaac Sim. Okay. Yeah, that's a very powerful difference between Isaac Sim and Gazebo, in case that you are into the reinforcement learning or even deep learning training world. So you are there. Great. And then, so let's say that some people in the audience, they are convinced to give a try. So can they just launch their current Gazebo simulations inside Isaac Sim? So there is a SDF to USD converter that was developed in collaboration with Open Robotics. And so, yes, you can go back and forth between USD and SDF. So, you might let's say build your environment in Gazebo and export it from SDF to USD, bring it into Isaac Sim. Maybe you want to tweak some materials to make it look better or something in Isaac Sim. But yep, you absolutely can go back and forth in that way.
Okay, and what about the URDF model of the robot?
Yep. So to get your robot into Isaac Sim, I think for ROS developers, the most natural way is just to import the URDF. And there's an extension for doing that in Isaac Sim. You just kind of go to the menu. There's a drop down. You say import URDF. You click some checkboxes and it pulls in the model. And again, you might want to tweak the materials or something. But in general, any robot you have as a URDF, you can pull right into Isaac Sim.
Okay, excellent. And then, so what about the ROS part? Because, so you get the robot inside there, you have the joints, and so what about, for example, what about the controllers of the joints? So what happens?
Yeah, so maybe it's worth me speaking for just a moment about how you program, because I described Isaac Sim as a platform. It's really sort of two things. It's a reference application. So you open it up, it's kind of ready to use out of the box. But the idea is that over time, a user might want to customize it by adding their own extensions, by maybe removing extensions they don't need. And there are multiple ways to extend the functionality of Isaac Sim. It's possible. Common way is to write extensions in Python. Another way is to write them in C++. And then there's also a visual programming framework called OmniGraph. And this allows you to build a graph out of nodes in a visual way where you're sort of dropping nodes onto a canvas and connecting them together with wires if you'd like.
But nodes, when you say node, you mean ROS nodes?
No, these are OmniGraph nodes.
Okay.
Very similar idea to the ROS graph, but these are OmniGraph is more focused it's more about manipulating USD, so properties of the USD
of the scene of the whole.
Which, by the way, yeah, USD itself is extensible. I probably should have mentioned that. So you can have USD schemas, and for example, there's a physics schema. So all the physical properties of an object, such as its mass and moment of inertia, and if there are joints in your robot, sort of joint limits, and all those properties can be represented in USD, and the joints of your robots can be controlled from OmniGraph. So you can build this graph in OmniGraph. You can do all your work just in the virtual world. Now, let's say, getting to your question, let's say that you already have a control stack in ROS and you want to control your virtual robot. Mm-hmm. The way that's done is through a ROS bridge. So that's bridging the ROS graph to the OmniGraph that you've created. And for example, the simulated state of the robot, let's say joint positions, can be passed as a ROS message to your ROS control stack, and then likewise commands can be passed in. Image data, if there's a simulated camera in Isaac Sim, that can be streamed out to your ROS application
as a topic. So there will be a topic with the camera information.
Yes.
Okay,
yep, exactly.
And then we would define this topic in the OmniGraph part.
Yes. Yeah. Basically, there's a node in the OmniGraph that
translates into ROS.
Exactly.
So that will be the bridge.
That's
right?
the bridge.
Okay.
And so there's a bridge for ROS 1 as well as ROS 2, currently we support Foxy and Humble for ROS 2.
Excellent. Then that means that if I don't want to add this bridge, then I can also continue operating with Isaac Sim in the language of Isaac Sim, right? Without taking into account ROS, right?
That's right. Yeah, I think ROS, it depends on the use case. We have plenty of customers who frankly haven't heard of ROS. You tend to see this like in industrial robotics, despite the valiant efforts of ROS Industrial and many other people. Not everyone has heard of ROS if you go to a conference like Automate, and so for them, their workflow might look a little bit different.
Yeah.
But I do think ROS is quickly gaining adoption even in that that area. So this is a major focus for us. So we're putting a lot of effort into improving the interoperability between ROS and IsaacSim.
Okay, yeah. Just to let you know that Gazebo also operates in the same way. So you can launch Gazebo in a standalone manner without having to interact with ROS, and then you have some other ways of interacting with the robots that you have there, because you are not interested on using ROS, for example, to control the robots. So it's the same way. Just wanted to see if IsaacSim was exactly the same. That in this sense.
same philosophy.
Same philosophy, exactly. Okay, then let me see, because I have many questions here, but we have already answered some of them, many of them actually. Then, so you mentioned about importing the robots from URDF or SDF, but also there is you also mentioned about an option about creating our own robots. So we can create them, and how do we do that? Do we have to type files like in URDF, or there is a graphical way of creating this?
Sure. So I mean, you could, let's say you have a brand new robot and you don't have a URDF for it. Mm-hmm. You could do basic modeling in IsaacSim itself. I mean, you can add primitives. You could build a robot out of, let's say, rectangular prisms and cylinders and things, and add joints. And certainly you could do all of that. I think what's more common is to build your robot in a separate tool, let's say in CAD.
Yes, exactly.
And then pull it in from CAD.
Import it.
And given the focus of Omniverse, there are CAD importers for all the common formats. There's also an importer from Onshape, which many users find convenient. Onshape is an online CAD tool. It's web-based. And so there's an importer where, either you bring a CAD file from somewhere else into Onshape and then import it, or do the modeling in Onshape itself and pull it into IsaacSim. And then within IsaacSim, you might do a little bit of work to like tweak the joints and so on to get it simulating well. Okay.
Then what about what is the next question? And yeah, so you mentioned that we can program our own routines there using an API, and you mentioned about Python. So is Python the main language that is used in order to program tools or applications or whatever for IsaacSim, or can we use any other language?
For writing IsaacSim extensions, the two that are supported are Python and C++. Mm-hmm. I think the vast majority of users today would use Python because often you're doing more high level scripting of behaviors or kind of piecing together existing extensions. So for example, you're using a very high performance LiDAR simulation, let's say, and then you might have your own network for let's say localizing an object or doing VSLAM or something. So all those high performance bits are probably written in C++ and exposed through Python. And then you're building the application itself in Python. And that can also include, customizing the UI. So some users are going to want to build their own application that might look nothing like what IsaacSim looks like when you first download IsaacSim. It's using all of the pieces under the hood. It's using many of the extensions, but the UI might be totally different. The user experience might be different. And again, for that, the whole UI can be customized using Python. And in fact, the documentation itself is sort of written in for the UI piece. Is kind of written in the UI language itself, so you can kind of see for each example how to add a slider or how to add a text box. So yeah, generally Python is the way to do it, but there is also C++. There's OmniGraph, and then you can write custom OmniGraph nodes in either Python or C++.
And now that you mentioned about the UI experience, the user interface, does it exist, a web version of the interface? It means when we install IsaacSim, then we have this Qt, I think it's Qt application, right? On Linux, on our Linux system, we have a Qt application, and then you launch it and so on. But my question is, does it exist a web version of the interface that I can access with a website, with a web browser?
So certainly a cloud version exists. So Isaac's Omniverse Kit and Isaac Sim don't actually use Qt. They kind of use their own UI framework.
Oh, okay.
Deep under the hood, it's using MGUI under there. But for cloud deployments, typically you would have an experience that would be in a browser, but it's not as though the buttons and so on are HTML elements. They're rather they're exposed through the browser as a streaming application. So one use case for Omniverse is, for example, very high-end car companies might have their car configurator. So you want to customize. Let's say you're buying a rematch or something, right? A very high-end supercar. You might want to customize it in the browser with, under different lighting conditions and see the materials and be able to go inside it and so on. And so that's an interactive application that runs completely in the browser. Robotics applications can be deployed in the same way, and you might want it to have a more restricted interface in a browser. It sort
just
of
like
depends who
a
the user is.
visualizer, for example, of the current scene of what the robot is doing, for example. So I understand that this can be done because you have access to the API. Then you can create your own web server and connect to the Isaac Sim, and then render into the web socket, and then somebody can pull it and so on. But my question is if there exists already a visualizer of the scene into a web. In Gazebo it exists. It's called GZ Web, right? That GZ Web is like the visualizer of the engine. So the engine of Gazebo is running in the background, and then you can launch either the GZ client, which is a Qt application, or you can launch the GZ Web, which is a browser visualizer of what is happening in the core.
Yeah. So when you launch Isaac Sim, by default, it actually first brings up an app selector because there's sort of different ways to run Isaac Sim, and one of them is streaming to the web. I think it uses WebDAV, but that may have changed.
Okay.
And that gives you the experience in your browser locally.
Yes.
For cloud deployments, I should also mention that there are containers you can download to easily deploy, either locally or in the cloud using a Docker container.
Okay. Excellent. Then, USD was here, but we already talked about it. And okay, so USD for ROS developers is a higher concept. I mean, but
it seems more complicated than you need, right?
Yes,
but
I think that is the way to go, because we are getting into this world where everything is replicated, and then we need to go far beyond the Chakro, URDF, and SDF. We need to go far beyond, and this is a first introduction into that format, I think.
Yeah, the way I would think about it, in the same way that a lot of the power of ROS comes from the community and from having a way to connect all these different tools and libraries and packages together, the world needed something similar for 3D assets and connecting together simulation tools. And that's what USD is meant to be. And Isaac Sim is sort of serving as a bridge between these two open communities of tooling, one for simulating 3D worlds and the other for building robotics applications. So I think that's the benefit. And even if you don't need the full power of USD today, you may find that you'd like it tomorrow.
Exactly. We are preparing here to the audience for the future. So yes,
that's right.
Then I don't know if you know my colleague. One colleague of mine is called Raffaello Bonghi. Do you know Raffaello, the creator of the Nanosword?
Yeah, I don't know him well, but he's been at Nvidia for a while, and he does all kinds of great stuff.
Yes, he's an amazing engineer. And then he was presenting at the ROS Developers Day, the conference that we organized. He was presenting last year about the Isaac Ross Gems. So he was presenting this concept, but I have been checking on the website. I don't know if this concept is still available or.
It absolutely is. And in fact, during ROSCON, which at the time we were recording this was just 2 weeks ago, we released Isaac Ross 2.0. And what this is, so for those who don't know, Nvidia, in terms of hardware, of course, we're well known for GPUs. We also build a series of embedded computers called Jetson, and they're geared for accelerated computing, so GPU accelerated computing. And that's motivated by the fact that, modern robots, as we were discussing, you might have multiple lidars and cameras, and that processing all of that data requires a lot of compute. And so that sort of motivates accelerated computing. And for that reason, there's a huge number of robots around the world built on top where the computational brain is Jetson. And to make it easier for robot builders, Nvidia for the last few years has been working on packaging up a lot of our perception technology, various AI models and so on, into packages which we call gems. So gems is just sort of the Nvidia term for a package. So these are ROS packages for doing different things, VSLAM, processing, stereo data, all sorts of things. You can go to the website and check it out. And they run either on Jetson, which, within Jetson is an SoC that includes a GPU, or let's say on a desktop with a discrete GPU. So that's Isaac Ross. And if this is confusing, because there's Isaac Sim and Isaac Ross, Isaac is just NVIDIA's platform for robotics. So basically anything robotics that comes from NVIDIA is branded as Isaac. Isaac and Isaac Ross Gem can certainly connect to Isaac Sim. And in fact, generally they're developed and tested using Isaac Sim, but they can also run standalone, right? You can use one of these Isaac Ross Gems without using Isaac Sim at all.
Yeah,
so
on the robot itself. On the real robot itself.
On the real robot. So the two are kind of complementary, but they're serving different purposes.
I see. Okay. Now it's a lot more clear. Yes, about the ROS gems. Yeah. So it looks to me like a kind of application, right? It's like an application that you download to your robot, and then it works with a few tricks and configurations. I understand, but.
Yeah, or it might be a building block for a larger
or something else.
So you have your nav stack, let's say, maybe let's say using nav2 in ROS2, but you need VSLAM, right? So you download this VSLAM package, and if you're using Jetson or another GPU accelerated platform, then you immediately get VSLAM for free, sort of a very high performance implementation that you can plug into the rest of your application. So you don't have to. It's the ROS philosophy, right? You don't want to do everything yourself. You want to grab the best pieces.
Yeah. Already, and somebody has done it.
Yeah,
and exactly. Dedicated the time to debug and to test and to make it. Okay.
That's right.
Okay. Great.
And NVIDIA is committed that you'll see a next version of the ROS gems, including additional gems and improvements to the existing ones over time.
Okay. Then one question about the costs. So you mentioned that for developers that are using this standalone, even in the companies, they are using for that. So it's free of cost, no cost. And then can we, for example, ship a simulation to one of our customers? So our company creates this simulation and as an example for our customer to see how the final product will look like and behave. Can we ship this to him and say, hey, just open this and then can we do this for free or?
Yes, you can. So it sort of depends on the scale. If you have an application that you are, what I would say is if you're deploying to thousands of customers, you might want to engage with NVIDIA and figure out how you can leverage everything behind Omniverse to make your application successful. Mm-hmm. On the other hand, if you're just starting out, I might point you can write your own extensions that sit on top of Isaac Sim. And an example of an open source project using Isaac Sim is one called Orbit. And Orbit is a collection of learning environments and interfaces. It sort of complements Isaac Gym in a way, but there's much more there in terms of pre-canned environments for training robots. Orbit lives on GitHub. It's open source. It's built on top of Isaac Sim. It's was developed by a collaboration between Nvidia, ETH Zurich, and the University of Toronto. And I think increasingly probably the community will get involved as well. And if you look at the installation instructions there, you install Isaac Sim from the launcher as you normally would. You clone this Git repository, and the extensions within that repository use Isaac Sim. So, it's an extra step for your end user, but I think for a typical ROS developer or someone in the open source community, it's not that bad to download these two things separately. Of course, it is also possible to build a more integrated application, maybe to deliver it from the cloud. I think that's a big focus these days, especially for industrial customers, is having it in the cloud.
Yeah, because it simplifies a lot.
Yeah, exactly.
Because it's running there, so you don't have to send them anything. They don't have to take any steps. Just run it there, and it's okay.
Yep. Yeah, exactly. And likewise, containers, even if you're not deploying to the cloud, it may be convenient to leverage the existing Isaac Sim containers to build on top of those.
Okay. And so we are about to finish this interview, and I have a final question. But before this final one, you mentioned that everything that is branded in Nvidia for robotics is called Isaac. Why is that? What's the meaning of this Isaac?
So I think even many NVIDIAns might not know where the name Isaac comes from.
No idea.
Historically, it was... so that NVIDIANs meaning NVIDIA employees. Historically, I think it was actually the confluence of two Isaacs. One is Isaac Asimov, of course, who's famous, among other things, for the iRobot series and so on. And another is Isaac Newton, because when NVIDIA first entered the world of robotics simulation, it was because we recognized we had this really good physics simulation technology, and robotics was a natural use case. NVIDIA is an AI company. Robotics is increasingly about embodied AI. And so it was natural for us to do something in simulation. And so that's where Isaac came from. It's sort of Isaac Asimov, as well as Isaac Newton. And those two, that's where the Isaac name comes from.
Okay.
Yeah, it's just sort of you could call it a brand. It is fair to call it a platform, because like all these different pieces talk to each other. Isaac ROS, Isaac. We have an Isaac AMR stack specifically for autonomous mobile robots, which is under very active development, and Isaac Sim. So all these Isaac pieces.
Okay. Yeah. We discussed here a lot of pieces of Isaac.
Yep.
I would say that it's getting more complex than understanding the organization of open robotics with the foundation, corporation, and it's getting. Okay, guys, don't get mad about this bad joke. Okay, just joking. Then, final question is: what can you tell us about the secret plans for Isaac Sim for the future?
Ooh, secret plans.
Yes, it's a secret plans.
I guess I can start with the not so secret plans.
Okay.
So a focus for us is always usability and improving usability over time. As we've been discussing, we start talking about USD and Omniverse, and there are all these pieces. I will say that when you actually download Isaac Sim and start using it, for most of the time you don't have to think about all of that stuff. But we would like to decrease the time to first simulation, let's call it, like getting robot working, and then also making it easier for developers who do want to go farther and build their own application. Isaac Sim has sort of been two things. I mean, one is it's a reference application. It's meant to be a platform, but I think we have work to do in terms of making the APIs, making them more usable. And then that includes, documentation and so on. So that's one focus. Not very exciting, but I think it's really important. Let's see, in terms of more, still not very secret. I think, one thing we didn't talk about the standard way to use Isaac Sim, let's say with a robot, is to pull that robot in as a URDF. We do provide some number of robots out of the box, both, mobile robots, legged robots, and robot arms. And we tend to add more in each release. Often that's at the request of the companies who make those robots. And we'll continue to do that. It's not really a goal of ours to add hundreds or thousands of robots. There's just too many in the world, and people create their own. So the workflow is more important. On the sensor side, though, I think there is a lot of value to providing calibrated sensors out of the box and enabling third parties. So let's say the sensor manufacturers themselves to build models that work in Isaac Sim. And so we are investing there. So RTX sensor is sort of this layer that takes advantage of ray tracing, for example, which is useful for cameras as well as, depth cameras and LiDAR, radar, and so on. So that's the focus. In terms of secret, secret to me means efforts that are not quite as far along, so you might not see in our next release.
Yes, exactly. Yeah.
But one, this is semi-secret, but we're among friends. One thing we're working on is enabling physics simulators beyond PhysX. So PhysX is the one that's developed by Nvidia. It is open source. You can go right now to GitHub and download PhysX 5. But I think it's natural for users, in the same way that Gazebo supports different physics backends, it's natural for Isaac Sim to do the same. Now, the tricky bit is doing that with the same level of performance that PhysX has, or at least not artificially. We don't want to add overhead in the interfacing between the physics simulator and Isaac Sim. And so we're working now on formulating like the best way to do that. But that's one thing that I think will be valuable to at least some users.
Yeah, very. Because
I don't think it's been talked about publicly before. So there's a secret.
Okay, thank you very much for this new that nobody else knew outside of Nvidia.
To be clear though, it's going to take us some time to get it right. So
yes, of course.
That's not a commitment. I'm not committing to a time frame, but we are absolutely working on it.
Okay, excellent. Then that's all for today about the questions that I have. I don't know. Thank you very much, Buck. It was a pleasure. We met first time at the movie day, and we managed to arrange the interview in only 2 weeks. That's a record.
Yeah, not bad. It would have been great to do it in person, but
yes,
I imagine
too many things in there.
Both of us, there's too much excitement at ROSCON. So this is the next best thing for sure.
Okay, so thank you very much, Buck, and see you around the world.
Yeah, thanks for having me.
Okay, people there, ROS developers over there, then this is all for this week. Remember to rate us in whatever the platform that you are listening to this podcast, Spotify, iTunes, whatever, this new application of our podcast that arrived. Please send us 5 stars if you like it. And if you don't like it, then send us an email. I will put a link on the show notes where you can send out your questions or your complaints or whatever you don't like it, so we can improve for you, because we are doing this for you to spread the knowledge of ROS around the world. So thank you very much. That's all for today, and see you next week with a new lesson from the experts. And until then, keep pushing your ROS learning.